So this is an area that I felt really strongly about making sure we start covering this via NAF. Come on up. And you know, my personal journey here is 18 months ago, I did kind of start out in the Skynet Matrix camp. I was probably afraid of the technology and its implications. And a couple key things influenced me. And per John Wallace's comments yesterday, you have to look outside your discipline to see what else is going on and how can it inform what's going on in network engineering. And you know, a couple external folks that really influenced me were Mark Andreessen from Andreessen Horowitz and from Netscape. And his piece in March this year, AI is Going to Save the World. That's a great read. I highly recommend you take a look at it. One of the other strong influencers is a gentleman who's supposed to be up here, but couldn't make it. Javier Antich, his book, AI and ML for Network and Cloud Engineering, was really a great gateway drug for someone with a network engineering and operations background to understand how AI and ML techniques play in here. Javier had to cancel at the last minute, unfortunately. He did send us a recording that we'll start out with. I think he's got some good perspective, so we'll start with that. Then we'll go to Igor and Dave, and Creedy's going to impersonate Javier. He'll do his best, and then we'll have time for Q&A here. So let me get the recording for Javier teed up. And while I do that, Igor and Dave, could you introduce yourselves to let people know your backgrounds?
Sure. Good morning, everyone. Igor Giangrossi. I'm part of the IP Networks division at Nokia, specifically working with the web scale segment.
Dave Siegel, Siegel Group LLC, here representing Selector AI, got about 30 years, mainly operational product engineering architecture experience with large telecom carriers.
And Creedy, we already covered Creedy. So let me see if I can get this to play.
Good morning, all. I hope we're having a good event so far. I would love to be here and there in person as soon as possible in time. But I want to thank opportunities Scott and Chris first for letting me participate in this panel, and also in this case, who's going through the video. I must share my thoughts on this topic. Some of you might know that I'm really passionate about the connection between machine learning and networking. And you gave me something back to write a book, referring to. So to write a book, to sort of share my learnings with you all about this, because I think it's really very significant, impact is very significant. But today, I want to discuss something that I find more profound and transformative. So let me share screen. So hopefully you can see my screen. So a couple of months back, I started working on an initiative that I call Anetta. The goal is to explore what could be the future of network automation, right? Through the use of what I call autonomous intelligent agents. And today I would like to share some of my thoughts about this in what I believe it is the next frontier in network automation. I think as an industry, you are all now inside a perfect storm. And let me elaborate why I think that is the case. First of all, network infrastructures are more complex than ever. They are larger than ever, and there are more moving pieces than ever. And that is a key factor that is influencing this. Second, the amount of qualified resources is more scarce than ever, driven in some cases by staff reductions, in some other cases by the lack of resources that know the technologies that are involved into these complex network infrastructures, but either way, the resources are scarce. And there is a third factor, which is that the network infrastructures, right, are more mission critical than ever. Or business, or economy, most of our life now depends on these network infrastructures. So this is the perfect storm that we are in, and we need to figure out how to navigate through it. But there is something that I find very disruptive happening, and I call it knowledge softwareization. Knowledge is now available in software. Knowledge is an inherently human-dependent resource. Right? Knowledge is sort of the combination between information, analysis, experience, context. But as a scarce resource, we have built our practices, systems, processes around that limitation, around that scarcity. However, all of a sudden, this resource now, it's available in software. And it's broadly available at the distance of a software API call. Something that was scarce, now it becomes, elastic, scalable, almost unlimited, right? This is the type of transformation that impacts economic systems. Something is scarce becomes suddenly broadly available and accessible. And large language models are a key ingredient in this process because they behave as huge knowledge compilators. So let's have a look at what has been going on in our industry across maybe the past 20 years and in this process that we could call the network softwareization journey. And it sort of started or is driven by the proliferation of standard APIs across all the different layers of the network infrastructure. And that triggers this softwareization process, more and more ability to control the network with software components, right? And on the other hand, it enables the more broad availability of network data through those standard APIs. But network softwareization and data lead into two key next ingredients. More decision points available, decision and action points. And with data, the possibility to optimize decisions, to run maybe algorithms to optimize those decisions. But the combination of these two factors leads to where we could argue that probably we are now, which is a sort of generation of networks that are reasonably dynamic, right? But in this puzzle, there are two new ingredients: cloud. And cloud enables new ways to do things that before were not possible. And the new kid on the block, the LLM, the large language models. We combine LLM, cloud, and data. We have all this powerful knowledge softwareization, knowledge compiling software. And if you combine knowledge compiling software with those decision points and the possibility to optimize decisions, you have the possibility to build autonomous agents, right? That can automate complex tasks and processes around those decision points. But now, if we combine the current dynamic networks with autonomous agents, we can take network infrastructure to a next level of autonomy or automation that was not possible before. So you see how this new component, the LLM, enables a new direct path towards what I call the next frontier of network automation through the knowledge softwareization and the possibility to build autonomous agents. What are these autonomous agents that I'm referring to? What are these agents? Today, we have large language models. You all know about them, right? They are very good at executing tasks. They can generate some text based on a prompt. They can summarize, they can translate, they can answer questions. You ask something and they go and execute, they do, right? their behavior, you could argue it's very much imperative. It is very prescriptive. You say what you want and they will execute. But now this is transitioning towards a more powerful architecture, which are the LLM-powered agents, which are complex problem solvers that can execute autonomously based on their internal capabilities, their ability to plan, their ability to execute functions, take actions, and to have memory, both short-term and long-term. And they are powered by language models. In our industry, we've been talking about intent-based automation for a number of years, right? And we usually refer to, when you define an intent, the user will define the what, but not the how. But somehow, someone had to define that how somewhere and program it in some rules. Now, with agents, the how can be generated automatically, with LLM-powered technology. Let me show you a couple of examples of what I mean with agents and the type of problems that they could help solving using the prototype of an agent that I've developed that I call Anetta, right? And you will see more, visually what this means. And by the way, you would be surprised how simple and easy it is to develop these agents, right? Because most of the complexity, it's already embedded or, comes, let's say, from the language model, right? All these agents are never developed with use case specific logic. But let's see this example here, right? We need to get some complex, query or to run some complex query on network information. And this type of question requires a reasonably strong ability to reason and abstract and figure out how to get the answer. But the agent goes and gets the answer. I never told the agent how to do any of this. The agent simply knows, right? Another interesting case, automating problem diagnostics, problem troubleshooting. We have a BGP session that is down, and the agent can figure out automatically what are the steps that would be required to troubleshoot this problem and how to find information required for each of these steps to figure out if, what is the root cause? Where is this problem coming from, right? Again, as in the previous case, I never told, the agent anything about how to do this, right? The agent knows by itself. It simply knows. So if we go back to the perfect storm that I was describing, I think now we have one component that, if not, definitive, that might definitely help in addressing or help us navigating through this storm, with the ability to augment what those resources can do and be able to deal with this network infrastructure complexity and their mission critical nature. And those ingredients, or that ingredient, are the LLM-powered autonomous agents. Right? So thanks a lot for your time. I hope you found this talk interesting and useful, and also we hope you continue enjoying the rest of the event. Thanks.
Thank you, Virtual Javier. Igor, to you.
Thank you. So I'll build a little bit on what Javier just mentioned. And I think the biggest question, and we had that question in the last session, was what do I do with AI? And how can I leverage all of the data that is generated from the network and use AI to build an outcome? So when we look at the typical uses of AI, and already covered that in the previous session, we go from very basic statistical analysis, very basic reporting or data analytics, where you do some just reporting, thresholding, the threshold generations, and you start using a little bit more learning, which gives you baselining of the network, and now you know if something is within bounds or out of bounds. And then you start doing some more anomaly detection or maybe some more outlier detection, all the way to the predictive part, which is to forecast how actually that network is going to behave given some input parameters. All of these use cases are not new. They have been enhancing the way they work and becoming more effective over time. But they're not new, and pretty much every vendor has a tool that provides you either some or all of these functionalities. In terms of Nokia, we do have NSP, which is our orchestration platform where you can essentially implement all of these tasks. And it's interesting to start looking at the way they've been deployed, which is primarily in a centralized architecture. And why is that? That is because when you start getting information from all of your nodes in the network and combine them together, that's where you get the best benefit. That's where you get the most effective insights. And the way you do it is essentially by collecting tons of data, petabytes of data or terabytes, whatever that is. You go through some AI/ML algorithms and you either generate some reports, or you can actually go further and start to predict some actions that, based on the given scenario, you would go back and take those actions into the network to make those networks better. Those could be either completely automated, or those could be operator-driven, where the system generates a suggestion and you go and do it. Okay, I still think, and we still think, it's probably well understood that centralized architecture is where you're going to get the best benefit out of the network, just because you have the network-wide context. But that doesn't prevent us from start looking, is there an opportunity for us to start using AI/ML inside the routers? And when you start brainstorming about that possibility, the first thing that comes to mind is, okay, what is the use case? Why would I ever do it? We got to have a use case, a reason, or an application, a way to get some benefit out of putting AI/ML inside the networks or the routers themselves. And very quickly, you start going into the practical details, which are, okay, AI/ML algorithms are essentially brute force. You throw compute, you throw memory, you throw disk at the problem, and you try to iterate, and then it gives you something back. Well, routers are not necessarily the best way to do that, or the best place to do that, because the CPUs, memory, and disk, the storage, they are not designed to run some of these algorithms. So they are designed to run network protocols, and you don't want to start adding cost into your routers just for doing that. And then you start looking at some other things, such as, okay, so how do I actually write an application to run inside my router? What are the data points that I'm going to getting? Where do I get it from? From logs? Do I get it from state? I changed the slide here. So just coming back here, what are the types of use cases that I'm going to get? Is it analysis? Is it just a closed loop? And if it's a closed loop, what do I use that for? Do I use it for enhancing routing, and so on and so forth? But then there are some interesting opportunities, which are, you have a lot of state, right? And it's not practical to stream all of the state from all of your routers in your network, but from a node perspective, you have all of that state available right there. So maybe you can take use of that. There's also real-time events happening, and most routers already have some sort of event handling tasks where you can react upon some sort of events and take actions, but is there maybe a place for AI/ML there? And we're seeing smaller models being created and some very use case specific training happening for some AI/ML models. So maybe there's a way for doing that. So what we did was, when ChatGPT came out as an LLM, we started looking, hey, is there any way for us to leverage that? And we combined that thought with the thought that maybe we should use this inside the router, just because an LLM is actually a text processor. You put some text into the LLM, and it gives you back some text. And hey, the CLI is nothing more than a text interface, right? So we use that text interface all the time. So how can we actually marry those? The other good part of LLMs is that you don't actually need to run the LLM inside the router. They have APIs, so you can actually just point to an API endpoint. You send some information, and then you get back that information, and you present that in a text interface, which is the CLI. So what we did was to leverage SR Linux. Here you have a very high-level overview of the architecture of SR Linux. It is a standard Linux distribution where we have a state sharing database that's accessed through gRPC and protobufs, and each of the protocols are individual processes. We provide an SDK, which we call the NetOps Development Kit. And as an experiment, we said, OK, what if we could write an application that makes use of ChatGPT to give us natural language interface with the router instead of using the CLI. So everything inside SR Linux is based on Yang models. So you create your application, and then you publish your Yang models. And what you get from that is all of the configuration and all of the state directly into the CLI. So it makes it pretty easy to do that. And that's what we did. So we went a step further and said, it's because LLM or OpenAI, ChatGPT doesn't know anything about networking, we need to provide some information for it to be effective. So what we did was we augment every single question that we get in this application with either some documentation. So we package all of the documentation into the application and index that in a database for us to be able to make use of it. Or we actually get live data from state, or live state from the box. Could be just counters, could be configuration. And we put a knob that if you want to send that information to OpenAI, you can. For obvious reasons, if you don't want to send that, you don't. You just disable that. And let me show you actually what it looks like. So this is a demo. Let's say I'm in the router and I want to troubleshoot some BGP. I don't know what's really happening. So the application gives you this command called Ask AI. And I go there and say, hey, can you explain how BGP failure detection works? I'm seeing some failures happening here. So in this case, it actually augments that question with some documentation. And you get a very nice description of the many ways in which SR Linux can handle BGP failure detection. So you can look, maybe there's keep alives, there's next hop tracking, and so on and so forth. And you can actually have a better view of what to look for. Then say, OK, I want to look at the configuration, but I don't know how to work with SR Linux. It's my first way doing it. So you can just go ask AI what command shows the running configuration. Again, we're going to get this question. We're going to send some context. And the LLM is going to respond to us with a very nice structured text that describes how you can show the configuration. So the info command shows the configuration, but because it's based on Yang trees, you can navigate the Yang trees and do context-aware configuration show. Right? So here I do a new chat. So just like ChatGPT, I don't want to carry on with that context because we do carry over the context through different questions. And here I want to display the route table. So I don't know if it's show route, show IP routes, or whatever. Just display the route table. And then in this case, we're actually sending state along with the question. And the LLM is going to do what it does best, right? Which is to get some data and present a natural language text. So in this case, it's describing the default context routing table and the management context route table in a text format. And then I can do something a little bit more advanced, which is say, are my BGP peers working properly? And what is BGP? What is peer? What is working properly? That there's a lot of uncertainty in that question. Nevertheless, we get some context, send that to the LLM, and it's going to say, hey, you got 2 neighbors, 2 BGP peers. One is working fine. And gives you the description, but the other one's not working fine. And it goes on to tell you, hey, it might be a configuration problem. And maybe I have a huge configuration. I don't know how to show just the portion of configuration for that specific neighbor. And I can ask AI, show the running config for that BGP neighbor. Again, it's going to take that question, get some interesting context that could provide the answer for that question, send that to the LLM, and then the LLM is going to get that, transform into a nice natural language type response, and display to you. So I went and took a look at the routing table, BGP peers, and a lot of other data without ever knowing a single command in SR Linux. So I don't even actually have to know anything. And I might even ask how some feature work if I never configured that feature, and I don't have to go elsewhere look for documentation. So you can try it yourself. I actually ran this demo on my notebook running Container Labs. By the way, we got plenty of Container Lab stickers in our table out there. If you love Container Lab, go grab a sticker. And you can actually download this app, try it yourself. We got a Discord channel where we're getting feedback, we're getting ideas. It's an experiment that we're doing, and we'll see where this takes us.
And while Dave comes up, I would encourage anybody who has questions, queue up at the floor mic so we can use the Q&A time best. Dave, it's all yours.
Thanks. I'm just glad I didn't have to follow Caridi directly. A little bit of space there is good. So I'm here representing Selector today. They have a platform for using AI-related technologies to mine insights from data and then improve operational observability. And I say that by way of setup because we thought about, well, what can we say in 10 minutes? And there is a maturity model that's defined inside Selector. This is contents based off of an internal paper, tries to define the framework and define some common definitions for things that we throw around a lot. And I think this might be useful for everybody. If you're early or haven't even started your journey yet, you're certainly going to need to try and convince people as to why this has value and help provide some definition here. So we're going to do some definitions and talk about the model and then talk about a use case. So by way of some early definitions here, monitoring is the foundation of everything. You can't do anything if you don't have telemetry data collected from all your devices. And the term MELT here, this is just metrics, events, logs, and traces. This could also include things like alerts and configuration data, and whatever your telemetry data set is goes in there. And the use cases for this are obvious. This is where you have maybe a plethora of standalone monitoring tools that are collecting their specific kind of data, processing their data well. But we don't really get into what we would call observability until you start to combine that data into one place. You're aggregating this data together, and that's going to enable you to start doing some root cause analysis, which is a really key use case in this space. To then take this to the next step, what we call AI Ops is this whole suite of additional capabilities and use cases. Simple things that are not really that simple, like noise reduction. They get much more efficient once you start to apply AI-related technologies to reduce noise as opposed to rule-based. But really the anomaly detection, like Caridi mentioned, basic statistical analysis, but also machine learning, doing that baselining, and we start to get into the self-healing aspect. So this is how we think about these things in terms of definitions. Applying those to the maturity model is where things start to get interesting. So anytime you start a company, you're probably sitting in passive ops, and this is the reactive mode. And you always want to move from left to right? You want to be more proactive. That's always the first goal. How do we become more collaborative? How do we solve things more quickly? And this is a natural phase, but it's really hard to get to this one stage. How do we become more mature? How do we not have to just react? How do we make the customer, not the monitoring system that's telling us when something's wrong in the network? How can we get ahead of that a little bit? So when we've graduated into this active ops stage, we're starting to get a little bit more collaborative. We still have some siloed observability tools, but we're starting to see a little bit more across the network. And the AI ops piece is where, we're not like, an artificial intelligence operations organization, but we're starting to use the AI technology tools to augment our operations and how we do things. We're becoming much more proactive. That's the signal of an AI ops-driven organization. And then the panacea or the utopia is to try and get to a no-ops phase where we don't have operations people sitting in seats reacting to things. We're able to do things using these technologies in a fully supervised but automated way with full autonomy. So the first step, the basic step, how do we get to be like an active operations organization instead of just being passive? Executive sponsorship, it always starts there, and this is going to be a theme for every phase through this maturity model. And if you don't have this yet, then maybe this presentation and these terms, this maturity model can help you start to get the executive sponsorship that you need to move through there. But it always starts there. And we're talking about an operations organization that's becoming much more oriented around tools, and not like the ticketing tool, but the actual tools that help you glean the insights. People becoming much more focused on the discipline of taking aggregated data and getting insights out of that, which translates into some of the key characteristics like the ability to do that proactive alerting and know when something is wrong, being able to filter out noise, but also prioritize what's coming in from telemetry data to understand where the most important issues are, and being able to actually measure your SLA compliance, both with your customers, but also internally across organizations, because you've got that tie between all the data that you're seeing and what that means in terms of results and what you're offering. To get from that into the AI ops from the active space, some of the key things around being able to graduate to this level of maturity is to really have the adoption of AI across your enterprise, like really have a discipline. Like today we're just dabbling, but to really think about how are we taking all these available tools and really integrating into the way that we operate. And that means just like anything else, not just training people how to do automation, but training everybody how to use AI and having that become part of the foundation of how they think about problem solving. Some of those key characteristics that you get out of that include the ability to do enhanced root cause analysis and to understand the anomalies that are presented there immediately. Your ops teams are no longer huddled around a monitor trying to figure out what the heck is going on, in your monitoring system and my monitoring system and how that all relates to the outages that we're having. We're now able to really collaborate because our tools are helping us understand that big picture. I want to take a little bit of time to talk about TracFone. TracFone Wireless is one of the nation's largest prepaid wireless providers, part of Verizon now, actually. And Selector was deployed into their environment up and down the stack. So a little bit about TracFone. They had 18 different monitoring tools, ranging from all kinds of network telemetry. They had lots of SolarWinds implementations, and they had multiple logging platforms. They had application tracing platforms that were looking at that piece. They had database telemetry coming in, all kinds of stuff. And they had really, really great people in each one of the domains that really knew their specific things. They had their DBAs that really knew how the databases functioned. They had their data center guys that knew the switches. They had applications guys. Everybody was great, but they'd have an outage and they really struggled across domain because they would literally have 6 people around a monitor in a cubicle, all trying to figure out what was going on. And that was kind of the problem that they had. So the Selector was implemented. They brought in the data from all 18 of those existing monitoring platforms. They applied AI-driven alert, filtering, and correlation, This is a big topic about how they do that. Selector's a sponsor back there if you want to learn more, shameless plug. But they brought all this stuff in, were able to filter out, reduce noise, provide that correlation, and then starting to create graphical dashboards that really created that observability between across all of these different types of data. And the results were they had a huge reduction in MTTR. So some of these outages that TracFone was having, because like if somebody goes to the TracFone website and can't up their prepaid time on their mobile, these outages literally cost like in the double-digit millions of dollars for a company like this because they're so e-commerce focused. They saw a huge reduction in the time to resolution for these larger incidents that they were having, and their overall uptime started to improve as well. So they're seeing fewer of these really large incidents as well. So really powerful use case there for that. I think that takes me out of time. So going to Q&A.
Very good. All right, I'm scanning for the microphones, and Otto Connors, you're up. So I see you in the middle here. Please go ahead.
Very nice sessions. Thanks for the speakers. SDN has been a popular word. I know Kiriti changed the defined into driving. My mother tongue is not English, so I keep trying to see the subtle differences between those words. To me, the defined is more towards the dev. Well, the driving part incorporates most of the operation we were dealing with on the network. I guess other speakers are also talking about operation here, operation there, troubleshooting, etc. So hopefully, can we also say self-operating network? That's the other words I used before. That's one comment. Fortunately, I have the opportunity to use machine learning approach on network data. To me, many of the network data, they are huge. There are all kinds of formats, but there are also a special language between machine and human. I see all the slides, right? All four speakers were talking about how they deal with the data. To me, I treat it as a language. Then we can use the computer language technique to deal with it. We actually get into those mode. So could all three speakers explaining how you guys treat your data, and then is any neural network or machine learning methodology has been used there? There are a little bit overlap.
Any takers?
So thanks for the question. Let me answer the last one because that's actually a favorite part of mine. When we first started talking about intent-based networking, it's like, what do you mean? Are you going to say, I would like my network to run well and walk away and expect something serious to happen? And the answer is no. So you have to couch what you want to say, the language in which you talk about intent, in a way that's actionable by the machine. And so my favorite example in this also, the project I've been working on for the last 4 years, is about service provisioning. And the idea of an intent model is turn the problem around and ask, what do my customers want from the network? And then say, how do I implement that? So I gave a little bit of an example of that with the network slicing piece. But a simpler example is, I want to create a layer 3 VPN. I'm back to my roots as a geek, as an MPLS geek. I want to create a layer 3 VPN with 10 sites, hub and spoke topology. Hub is dual home, spokes are single home. Hub connects at 10 gig, spokes connect at 1 gig. Make it so. Picard is my ultimate intent compiler. So the idea that you can couch what you want, it is not as high level as intent could be, but that language is something that we can then action and make the machine, make the system do. So I think we need to be, I totally agree that the language in which you say this is very important. And for me, that language starts with a model. And if you have the right model, then you can actually do a lot of things like validate, the request, then make the request happen, and then see once the request has actually taken place. I mean, you've compiled it down to all these instructions to all the devices. Is my original intent actually being satisfied? So I think that the idea of being able to couch the intent in a language that's actionable and then say, here's the experience. It reflects or does not reflect the original intent. I think those are all aspects of the language/model in which you interact with the network.
Is this thing on? I gotta wait for the sound guy. I think there's like three things before you can get there. So the first is the data. All the data has got to be in one spot. You can't employ a language model to do anything unless it's got a bunch of stuff to look at and try and glean information from. So that's number one. Number two, you need standards and also metadata to provide context around all that data, which is like the next really big piece of making sense out of all this. And then I think you get to the big part of what Kurti was saying, which is what's the intent, which is another way of saying that is, well, what am I supposed to do with all this stuff? This stuff has some purpose for living. If you combine all those three things, then you can start to employ AI in a way that can make sense of all of these three things and help you do some interesting things. That's my opinion.
Yeah, I agree. And I'll just add that AI/ML usage is a very iterative process. So it's not you do something and you get the response right away. You got to get your data, run some analysis, maybe you find some anomaly, and then within that anomaly, you start analyzing other data that occurred at the same time, and maybe some of the other data will correlate, maybe some of the other data won't correlate, and then you start playing with the data until you actually find information that contributes to the use case, and then you start refining your model to say, hey, whenever A happens, B is going to happen. So until we reach that point, there's a lot of human intelligence that needs to analyze the input and the output of the artificial intelligence until you can actually offload that task completely to artificial intelligence. So it's a long iterative process.
Thank you. I think stage right, I see Brandon.
Brandon Bennett. I wanted to dig a little bit into the LLM use case. I think it's a transformative technology. I pay the $20 a month for ChatGPT-4 to ask programming questions, but it's wrong more than 50% of the time. I have enough knowledge and background to kind of jump into and say, hey, you know what, you're wrong. And I actively jump in and actually argue with the thing for some reason. But no, you're wrong. Oh, you're right. No. Anyway, do we actually see this as a forward-looking technology? Because the examples that have been given so far have been extremely trivial, things that could be done on ChatGPT without having a router. For the most part, like, is this a thing that we think that the technology is going to catch up to it? Because what I see right now is it seems very almost like a novelty. So I'm kind of curious on where we see LLMs really fitting into network automation more.
Well, I think they play some very useful roles in some of the technology today that you may not be aware of. And I'm not talking about the application of ChatGPT specifically, but in Selector's case, they've been using a smaller language model for a while to interpret and extract metadata from syslogs, which are different across every device and, in fact, different across different models within the same vendor. Sorry. But that's been a really good application that they have launched early on that uses a simpler language model to do things like that. And then they also use it for spell checking and things like that in terms of making sure that when you're asking for some data, it gets you to an actual mapped query that can provide you with some useful data. The next iteration of that, which is pretty exciting, is to use a much larger language model that actually goes and finds data out of everywhere and tells you what it thinks you want to know across all the data that is sitting in there. But that is employed in a platform managed by people that are directing it at your specific data sets and helping to train that to do things. So I think where you're coming into play is you're using a generic large language model to try and tell you interesting things, and it's confused about all the different conflicting data out there and trying to pick a couple and show them to you. But having said that, it is very nascent in terms of the technology, so it's to be expected.
Yeah.
If you can keep your responses brief, I'd like to work in one more question.
Sure. I agree it's an emergent technology, and there are some ways in which you can make it better. One of them is the technique we use here, which you can call RAG, Retrieval Augmented Generation. So you actually give more context within the prompt such that a generic model gives you the answer. The other is actually either fine-tune the model or completely train another model with the specific use case. And training a model is very expensive, right? It takes a lot of GPU and so on and so forth. So I think we're just in the beginning of LLMs, and we're going to see a lot more down the road.
So I'll keep this brief. There's a huge difference between ChatGPT 3.5 and 4.0 or 4. Having said that, I don't know if any of you actually had used the term or heard the term hallucination, AI hallucination, before ChatGPT came around. It's actually real, and people are on the verge of losing their jobs and various other really negative consequences. So using ChatGPT for non-trivial things, and not just ChatGPT, but the underlying LLM for non-trivial purposes, is something to be undertaken with a great deal of care. I'll leave it at that.
Very good. Well, if it pleases the court, we'll just go a little over. John, yep, you're next.
Yeah, first a comment is the RAG, the man for Nokia, the hallucination thing has been basically solved by vector databases and retrieval augmentation. So, and people are using serious applications today using RAGs. So that hallucination thing is true, but it's if you're working against the core GPT-4 LLM. The question I had for the Nokia gentleman is, you partially answered it because I really don't understand why you would actually run it in a router as opposed to outside of a router. It just seems illogical. But I was hoping that you weren't going to say that you were actually using the context window to send the data out to the SAS, OpenLLM SAS. But you are putting a vector database in the middle of that somewhere, obviously, hopefully not on a router.
No, it's all internal to the application. So the application itself has a little vector DB, and we augment that.
So you put a vector database like a Chroma DB actually on the...
Yeah, it's a small application. It's a text, right?
Okay.
And we give it not only the documentation, but also some instructions on which state to fetch from the box.
Yeah, I'd love to talk to you. I just don't understand why you wouldn't use like a Pinecone or use one of the standard, very powerful vector databases outside of the router as a breaker between that.
We could. Actually, we're exploring all of these. This was an experiment, as I said. What can we do just inside the router?
Okay.
It was only that.
Yep.
Very good. Many good questions, Sanat and others. I apologize. We must keep the trains running on time. So let's thank our panel for their participation.